Now, this is something like this is something like this, real part and imaginary part. Now, given this, can I find this? Or given this, can I find this? This will only happen when this is causal, this corresponds to causal, right? That means now, if this, what is the speciality of the causality? If Ft is causal, f omega, which is the Fourier transform of the causal function, what is the properties of the Fourier transform? This must be analytic in the right half plane. Remember your transfer function. It should be analytic in the right half plane. That means no poles in the right half plane. So, if the function has no poles in the right half plane, f of s does not have poles in the right half plane, then this inverse transform of that will correspond to a causal function. Now, h j omega is a transfer function, and we have studied in 101 that transfer function also must have poles in the no poles in the right half plane, but zeros can be anywhere. So, pole portion is taken care of, no poles. So, logarithm of at the pole problem does not exist in the right half plane, because if there is a pole in the right half plane, logarithm will also be a pole. So, since there are no poles in the right half plane, so there is no issue about having a pole in the right half plane. Now, what about zeros of h j omega? It can be anywhere in theory, but if it is in the right half plane, what happens? Then the 0 will become logarithm of 0 will become a pole. So, if you do not have zeros in the right half plane for h j omega, substituted s is equal to j omega, and then this function will also be corresponding to a causal function. Is my argument clear or not? No. Remember transfer function h of s is equal to p of s by q of s. Since it is a transfer function, the zeros of qs cannot be in right half plane. Right? But zeros of p of s can be in right half plane. This is what we learned from 101. Now, I am taking log of this. Then, if there is a pole here in right half plane, if there is a pole, then log will also have the same pole at the same point, because log infinity is also log infinity. But anyway, there is no pole in the right half plane, so there is no pole in the function log h in the right half plane. But zeros of this can be there in the right half plane. The 0 which is the right half plane, logarithm of 0 will also be a pole. So, which is not allowed in the right half plane, because this function has to be causal function. So, which tells you that we cannot allow p of s also should have zeros in the right half plane. So, if there is a transfer function which does not have zeros in the right half plane or poles in the right half plane, only such transfer function will have the relationship that alpha and theta omega are related by Hilbert transforms. If there is any zeros in the right half plane, then obviously this relationship is not valid. Okay? They are not related by Hilbert transform. If you have a transfer function like what you have written there, h of s, p of s by q of s, if this has a 0 in the right half plane, so p prime s, which is the without the 0 in the right half plane, and say only one pole, 1 0 in the right half plane, which is equal to s minus s naught. You understand what I am writing here? This PFS polynomial has only one 0 in the right half plane. That 0 I am pulling out. Remaining portion is my P prime S, which doesn't have any zeros in the right half plane. I can now do the following. This is equal to P prime S into S plus S naught right, multiply numerator denominator, and where is this pole? Now there is a pole here, right? Where is this pole? S is equal to S naught was 0, so S naught is the right half plane. The pole is at minus S naught, it will be the left half plane. Left half plane is allowed. Now this function now, so this has now a 0 in the left half plane. So the 0 in the right half plane is now converted to 0 in the left half plane as far as this is concerned. That 0 is pulled out as a pole here, multiplied by the original 0 here, and this function magnitude is equal to 1, because S minus S naught by S plus S naught. So you find out the magnitude of this function S is equal to j omega, the magnitude will be exactly the same, the phase will be doubled up. So this transfer function of this portion of this is just equal to unity gain, but only a phase variation. Whereas this port, what is left here is now a function with both poles are zeros in the left half plane, and this function people call it as minimum phase function. This is called minimum phase part of the transfer function, and this is called the all pass function. Why is it called all pass? Because transfer function is equal to 1 for every omega, so it passes all frequencies, so it's called a all pass function. Only thing is modifies the phase. So any function with a 0 in the right half plane can be converted into a product of two transfer functions. One transfer function corresponds to minimum phase, and the second one corresponding to an all pass. All pass doesn't modify the magnitude variation, it only modifies the phase variation. Okay. So in this language, if Hs happens to be a minimum phase function, which by definition has zeros in the left half plane and poles also in the left half plane. If that is the case, then alpha and omega theta are also related by Hilbert transforms. This clearly tells you. Now next question is, somebody says, I want you to design a network with a given alpha omega, amplified design. I want a transfer function whose magnitude, logarithmic magnitude is equal to given alpha omega. Can you design the network?